Now the next topic is the measure of the angle between two lines in space. That is, suppose the first line is vector equation of that line is vector r is equal to vector a plus k times vector l, where k belongs to r, and another line with vector passing through vector b and k times vector m for all k belong to r be two lines in space. Now first, if vector L is equal to vector M or vector L is equal to minus of vector M, then cross product of L and M is 0. That is, measure of the angle between two lines is 0. Now the second point, if vector L is perpendicular to vector M, that is dot product of L and M is 0, then the lines are mutually perpendicular lines. That is, the angle between these two lines be pi by 2. Now the third point is, if dot product is not equal to 0 and cross product is not equal to 0, then acute angle alpha between the lines is given by, that is, cos alpha is equal to modulus value of L dot M, that is a positive value, over magnitude of L vector into magnitude of M vector for alpha lying between 0 to pi by 2. That is the way how can we measure the angle between two lines. That is, it depends upon the direction of, that is, a line parallel to that in the direction of that vector, that is vector L and vector M. Now we are going to find the condition for intersection of two distinct lines. That will be find out by stating and proving theorem 7.2. If two distinct lines with vector r is equal to vector a plus k times vector l and k belongs to r, and another line, that is vector r is equal to vector b plus k times vector m for k belongs to r, intersect in a point, then A minus B dot cross product of L cross M is 0. That is, we have to find position vector of A minus B and then cross product of L and M and then taking the dot product. If it is come out to be 0, then two lines intersect at a point. That is, suppose two distinct lines vector R is equal to vector A plus K times vector L for K belong to R and vector R is equal to vector B plus K times vector M for K belongs to R intersect at vector C with position vector C. Therefore, C will lie on the equation, both the equation, that is vector C is equal to vector A plus KL, also it is further equal to vector B plus KM for all, that is, here both K's are not equal, so we take K as K1 and K as K2 and also in the here K1 and K2, where K1, K2 belongs to R. Now, as K1, K2 belongs to R, now we take A minus B. From here if we see, we get vector A minus vector B, that is equal to vector K2M minus K1L. So now we take the A minus B dot L cross M, that is K2 vector M minus K1 vector L into L cross M. So we get K2 vector M dot L cross vector M minus K1 vector L dot L cross vector M. That is, scalar triple product is 0 when two vectors are same. So here two vectors M and M are same and here two vectors L and L are same. So it becomes K2 into 0 minus K1 into 0 all over it is 0. That is, if two lines intersect at a point, then vector A minus vector B dot cross product of L and M is equal to 0. If we write in the component form, let's see. If vector A is x1, y1 and z1 and component of vector B is x2, y2 and z2 and component of vector L is L1, L2, L3 and component of vector M is M1, M2, M3, then the condition A minus B dot L cross M is equal to 0 is transformed into, that is determinant of x1 minus x2, y1 minus y2, z1 minus z2 in the first row. In second row, component of L, L1, L2, L3, and in third row, component of M, M1, M2, M3, that determinant 3 by 3 is 0. This is the Cartesian form of condition, that is Cartesian form of above condition, that is when two lines intersect, we have to take the determinant value of x1 minus x2, y1 minus y2, z1 minus z2 as first row component, and second row elements are L1, L2, L3, and third row elements are M1, M2, M3, and then finding their determinant we get it is at 0, then we say that two lines are intersect. Now we are going to solve problem based on measure of angle. That is the first one. Find the measure of angle between the lines x minus 2 over 2 equal to y minus 1 over 2, z plus 3 over 1, and x plus 2 over 4, y minus 4 over 1, z minus 3 over 8. Now the solution is, let line L is x minus 2 over 2, y minus 1 over 2, and z plus 3 over 1. And if we see here, L component are 2, 2, 1, that is these components. And let line M, that is x plus 2 over 4, which is equal to y minus 4 over 1, which is equal to z minus 3 over 8. That is here M is with component 4, 1, 8. Then by definition of measure of angle between two lines, if alpha is the angle between the given lines, then cos alpha is equal to modulus value of L dot M, that is dot product, over magnitude of vector L, magnitude of vector M. That is, if we take the dot product of L and M and their magnitude, we will get the value of cos alpha by substituting this value in number 1. Therefore, L dot M is equal to 4:2, 8, plus 2 into 1 is 2, 8 into 1 is 8, that is 18. So its modulus value is also 18. And what is the magnitude of vector L? That is under root 2 square, that is 4, 2 square, that is 4, plus 1 square, that is 1, that is under root 9, that is 3. It's a modulus value, so it is positive. Now the magnitude of vector M is under root 4 square is 16, plus 1 square is 1, and 8 square is 64. So it gives under root 81, that is modulus value of M is 9. Therefore, using number 1, we get cos alpha is equal to 18 over 3 into 9, that is 9 twos are 18, that is we get 2 over 3. Therefore, angle alpha is cos inverse 2 by 3 is the angle between two lines. Now the next is, if the line x minus 5 over 7, y minus 5 over k, z minus 2 over 1 and x over 1, y minus 3 over 2, z plus 1 over 3 are perpendicular to each other, then find k. That is, angle between two lines is 90 as they are perpendicular, and their dot product, then it will be 0. Here if we see, L vector is from first line is 7, k and 1, and M vector from second line is 1, 2, 3. As the lines are perpendicular, therefore vector L dot M is equal to 0. So we take the dot product of L and M. 7 into 1 is 7, plus 2 into k is 2k, plus 3 into 1 is 3 is equal to 0. So that gives 10 plus 2k is equal to 0. So that gives 2k is equal to minus 10. So that gives k is equal to minus 10 over 2, that is minus 5. Therefore, when the lines are perpendicular, and from that given condition, we get the value of k which is equal to minus 5.